Good afternoon, my Algebra 1 babies. I love you so much, and I miss you guys, and I hope that you are staying safe. I hope that you guys had a great weekend. We are going to move on to lesson 6.5 today. We're going to do linear inequalities. So for today's lesson, you're going to need a paper, you're going to need some pencils, basic calculator, you're going to need your textbook. We're going to be on page 394. You're going to need access to your RenWeb to download the homework, and also to be able to send the homework back through Homework Drop. Now, if you do not have Microsoft Word, please let me know. I have also sent an email to your parents as well as you, so whatever email you have on file with RenWeb, that is where the email went to. So if you have the wrong email address in there, you'll have to let me know because it wouldn't be able to be delivered to you. So again, we'll work on those issues later on if you have problems. All right, so we're going to go ahead and get started. So I'm going to take this page off, and we're going to get going. So today we're going to talk about linear inequalities, and we're going to start off first of all with example 1. All right, so for example 1, we're going to start with identifying solutions of a linear inequality. That is identifying solutions of a linear inequality. All right, so let's talk about that. Linear. What word do we see in linear? That is correct. We see the word line in linear. That means when we graph these, we're going to have a straight line. What do we know about inequalities? That's right. Inequalities are our less than, greater than, less than equal to, or greater than equal to. So we got our 4 symbols, so I'm going to go ahead and make sure we write those symbols down so you guys have them. Okay, so we're going to write that first. This is our less than symbol. And this is our less than or, and that's important because it could be one or the other. So less than or equal to. Doesn't have to be both. It's not less than and equal to. It's less than or equal to. We'll switch out a color so we don't have the same color floating for the other symbols. We'll do greater than. And then we'll do our greater than or equal to. All right, so here we have our 4 inequalities. So we're going to look at a given inequality, and then we're going to look at a solution and see if that solution would hold true in that inequality. All right, so let's get us a given inequality. All right, so here we go. So our given inequality is y is greater than x minus 3. All right, so we know that this would be, move this up a second, it will be linear because we do only have a degree of 1. So our x is raised to the first power, which makes it linear. And the question that we're posing is the point 1, 2 a solution? So we want to find out, is the point 1, 2 a solution to this inequality? So to determine if it is a solution, we have to first identify what does 1 represent and what does 2 represent. In an ordered pair, think things alphabetically. Think about your alphabet. So x is our first value and y is our second value. And alphabetically, x comes before y. So now we know that x is equal to 1 and y is equal to 2. So if we know x is equal to 1 and y is equal to 2, we can substitute those values into the given inequality and see if it holds true. So since we got our inequality as y is greater than x minus 3, we're going to substitute y with 2, and we're going to substitute x with 1. All right, since there are no values out front to multiply this 2 by, it just stays 2. Greater than. Since there are no values in front of this 1 to multiply the 1 by, we just leave it as 1 minus 3. So now we need to solve. So we can't do anything with our 2, and we can't do anything with our symbol. We'll move this up a smidge, and then we'll solve. 1 take away 3 is negative 2. So the question is asking is, I'll write this down in words for you guys, is 2 greater than negative 2? Is 2 greater than negative 2? That's the question. The answer to that question is yes. 2 is greater than negative 2. So therefore, 1, 2 is a solution. Everybody okay? All right. So now we also want to ask the question, is the point negative 3, comma, negative 7 a solution? So now we want to find out, is negative 3, comma, negative 7 a solution? So again, just like the first one, we need to identify who our x is and who our y is. So now we know that x is equal to negative 3 and y is equal to negative 7. So we're going to bring down our given inequality. Y is greater than x minus 3. From here, we'll go ahead and substitute. We'll take out our y value and put in negative 7. We'll take out our x value and put in negative 3. Since there's no value in front of our negative 7 to multiply it by, we just leave it negative 7, our greater than symbol. There is no value in front of our negative 3 to multiply it by, so we just leave it negative 3. Take away 3 more. So we bring down our negative 7. We bring down our greater than symbol. Negative 3, take away 3 more, is negative 6. And the question is, they're asking, is negative 7 greater than negative 6? The answer is no. So this means negative 3, negative 7 is not a solution to the given inequality. Oops, our picture's not there. Let's pull that up real fast. So again, the question was asking, is negative 7 greater than negative 6? No. So therefore, the point negative 3, negative 7 is not a solution. All right? So we're going to go ahead and we're going to turn in your books to page 397. So I'm going to bring this back down real fast. If you need that, go ahead and pause, rewind, take a moment to get what you need. We're going to go to page 397. So I'm going to write that up at the top. Page 397 is where we're going to be. Page 397. And we're going to try problem number 8. All right, so number 8 says y is less than or equal to negative 2x plus 1. Now they have this little semicolon next to it, and they have 2, 2. So what they mean by this is they're wanting us to substitute x for 2 and y for 2 and see if this solution holds true. So first identify, this is our x value, and this is our y value. So this means x is equal to 2, and y is equal to 2. So they're wanting us to substitute those two values in. So we're going to go over here, we're going to replace our y value with 2, less than or equal to, negative 2 times our x value of 2, plus 1. Since there's no values in front of our 2 to multiply the 2 by, it stays 2. Then we'll distribute. Negative 2 times 2 is negative 4, plus 1. Our 2 stays just the same. Negative 4 plus 2 is equal to negative 3. So the question is asking us, is 2 less than or equal to negative 3? What do you think? Tell me what you think, Ethan. Is 2 less than or equal to negative 3? You're correct. The answer is no. It is not. So therefore, the point 22 is not a solution. Okay? Let's go ahead and try number 9. I'm going to move it up a little bit. Okay, number 9. It has x is less than 2, has a semicolon, and the point negative 1 and 0. So we want to go ahead and first identify in our ordered pair. This is our x value, and this is our y value, which means x is equal to negative 1, and y is equal to 0. When we go to substitute in, we notice we only have one variable, and that variable is x. That means we do not have to substitute the value for y. So we're going to substitute our value for x, which is negative 1, and then we say less than 2. There's no number in front of our 1, negative 1 to multiply by, so it just stays negative 1. And we bring down the less than and the 2. So the question is asking, is negative 1 less than 2? What do you think, Mia? Is negative 1 less than 2? You're correct. Yes, it is. So this means that negative 1, 0 is a solution. All right, we'll try another one. We're going to go ahead and try number 12. So I'm going to bring this screen up just a smidge so you guys can see. All right, we're going to start with number 12, which is y is greater than or equal to negative 2 over 5 times x plus 4. And it gives us the point 0, 0. So we still got to first identify our value for x and our value for y. So here we have x is equal to 0 and y is equal to 0. So we'll go ahead and we'll substitute. We'll replace our y value with 0. Bring down our inequality sign. Negative 2 over 5 times 0 plus 4. There is no value in front of our 0 to multiply it by, so we just leave it 0. Our greater than or equal to symbol will distribute. Negative 2 over 5 times 0 is 0 plus 4. We'll keep our 0. Greater than or equal to 0 plus 4 is 4. The question is asking, is 0 greater than or equal to 4. What do you think, Cheyenne? You're correct. No, 0 is not greater than or equal to 4. So for no, that means that 0, 0 is not a solution. All right, we're going to try one more in this section. We're going to move to number 13. Number 13. All right, we got 3y is greater than 5x minus 12. And the point they want us to check is negative 6 and 1. So what we first must do is identify who our x value is and who our y value is. So this tells us that x is equal to negative 6 and y is equal to 1. So now we're going to go over to our inequality and we're going to substitute. So we got 3, then our y value, which is 1, greater than 5, then our x value, which is negative 6, minus 12. This time we have a value in front. So we're going to multiply 3 times 1 using that distributive property. 3 times 1 is 3, greater than, using distributive property, 5 times negative 6 is negative 30, take away 12. We'll bring down our 3, our greater than symbol, move this up a little bit more, negative 30, take away 12 more is negative 42. So the question is 3 greater than negative 42? What do you think, Fabian? Is 3 greater than negative 42? You're correct. Yes, it is. So then the point, negative 6, 1, is a solution. Fantastic job on that. All right. So now we're going to turn back in our books to page 395, and we're going to look at example 2. So I'm going to move this back down real quick. Get this up in our screen, and then I'm going to move the page out of the way. Again, you can pause, rewind, whatever floats your boat, so that way you can see everything or get everything you need. So we're going to start with example 2. So example 2 is graphing an inequality in 2 variables. So graphing an inequality in 2 variables. Now you have already learned how to graph a line in 2 variables using x and y. Remember the slope-intercept form, and we've learned to graph with standard form. So we've learned both ways. We've learned when we have y equals mx plus b, that's our slope-intercept form, and we've learned standard form, ax plus by equals c, standard form. But when we talk about inequalities, now the symbol here changes to inequality. This becomes an inequality. And the same thing would hold true on our standard form. This becomes an inequality. All right, so we're going to look at a problem together, and let's see how we do. They're giving us the inequality y is greater than x minus 2. So we're going to first ask ourselves, is it set up in the slope-intercept form or is it in the standard form? So let me go ahead and write those names above those real quick. This is slope-intercept. And this is standard. All right, so we're going to go ahead and make sure we have those documented. All right, so I'm going to go ahead and let's see if I can get us a line. So I'm going to try to create us a graph. The best I know how, because I don't have graph paper. So you at home may not have graph paper either, or you'll be on the computer that will. All right, so Angel, is this in slope-intercept form or standard form? You are correct. It is in slope-intercept form. So this is slope-intercept. All right, so there are two very important things that help us to graph when we are in slope-intercept form. The first thing we need to know is our slope. That is our m value. And notice that our m value is the coefficient of our x. It is not x, it's just the coefficient of x. So let's go to our problem. We have an x, but I don't see a number there. So what is that coefficient? That's right, Amaya, it is 1. It is an understood 1, so the slope of our line is 1. If we want to write this in the form that slope, remember, is equal to rise or fall over run. And we usually try to go run right. Only time we don't go run right is if we cannot rise enough or fall enough, and then we make changes. All right, so if I want to change this to a fraction, 1 divided by 1. So that means I'm going to rise 1 and I'm going to run right 1. So that was my information on my slope. The next key piece of information that comes from our slope-intercept form is our b value, which is our y-intercept. So the value located in the b is this entire back end. If it's plus, it's a positive b value. If it's a minus, like in our problem, it is a negative b value. This is our negative 2. This is our y-intercept. This is the starting point. So I'm doing a little bit of reviewing just in case some of you still are not sure how to graph these. So if you're graphing these online on your Math Excel for School program, you're going to first click on the line tool. The first point you will plot will be negative 2. So it means you're going to go down 1, 2, and make a dot right there on the y-axis because it's your y-intercept, so you need to be on the y-axis. From here, you will apply your slope. So from this point, we will do what the slope says. Rise 1, and we're going to run right 1. So rise 1, so go from here to here, go up 1, and then we'll go to the right 1. Now, with inequalities, there are a couple things that we have to know about our inequalities. I'm going to write this over here on the side. If we have less than, we want a dotted line, dot, 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 dot. If you have a greater than symbol, you also have a dot, 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 dot line, like a dashed line. But if we have less than or equal to, we have a solid line. And if we have greater than or equal to, we have another solid line. So the easy way to remember is if we have a solid bar under our inequality, then we have a solid line, which means we are including all the values on the line. But if we do not have our solid bar, that means we have a dotted or dashed line, which means we do not include the values on the line. So when you are graphing these in your Math Excel for School, when you click on your line tool, below it will show a solid line or a dashed line, and you'll need to pick the correct one. For this one, we'll need to pick the dotted line or the dashed line because we do not have a solid bar. So we're going to put our little dot, 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 and make our little line. And put our little arrows. Now your program will automatically create those lines for you, just as long as you put the dots in the right locations and choose the correct line, solid or dotted. This next part talks about shading, where we got to shade on the proper side of the line. We got to shade all the values that would make this true. So to do this, we're going to pick a test point. And the test point we want to pick, as long as our line does not pass through the origin right here, which is 0, 0, we're going to make 0, 0 our test point, because it's easy to replace values with 0. So we'll remember our values. This is our x value, and this is our y value from example 1. So we'll replace y with 0, greater than the x value, minus 2. There are no values in front of either 0 for us to distribute to, so we have a 0 greater than 0 minus 2. So 0 take away 2 is negative 2. So we're asking ourselves, is 0 bigger than negative 2? Yes, this is a true statement. So this is true. If it is true, you will shade on the side where your test point is. But if it is false, you would shade on the side opposite of your test point. Now in your program, you're going to have these little paint buckets that you're going to drop in. So you drop a paint bucket in on the side and saying every value over here would be true. All right, we're going to do another one. So I bring this page up a little bit. Trying to make sure you get the whole bottom half of the paper here. All right, there we go. All right, we're going to do another example. We're going to do y is less than or equal to 1/2 x plus 1. All right, so the first thing to do is look at our inequality and determine, is this in slope-intercept form or is it in standard form? So, Isaiah, what form is it in? Slope-intercept or standard? That is correct. It is in slope-intercept form. So since this graph right here, let me switch out some colors, is in slope-intercept form, we can go ahead and identify our slope. So what value is our slope? Who remembers how do we find our slope? That's right, Laquan. It's the coefficient of our variable x. So our coefficient right there is 1/2. So my slope is 1/2, which means I'm going to rise 1 and I'm going to run right 2. The next value I need to find is my b value, or my y-intercept. Mia, what would that be? That is correct. It's a positive one because it says plus 1. So this is my y-intercept. This is my starting point. All right, so now I'm going to go ahead and make yourself a little graph. I'm going to go ahead and try to do that real fast for you guys. All right, so we're going to go ahead and plot our first point, which is y, which is 1. So we're going to go up 1 on the y-axis and put our first dot. That is our starting point, our y-intercept. Our slope is 1/2. So from this point, we will rise 1 and then run to the right 2. So I'm going to go ahead and put these since I'm running right 2. So I'll rise 1 and run right 2. The next thing I have to determine, is my line going to be solid or dotted? So when I click on that line tool, I need to determine, am I clicking the dotted line like from above, or am I clicking on a solid line? What do you think, Lakeisha? You're correct. Solid line, because we have this solid bar right underneath our inequality, so we're going to have a solid line. So we're going to make a solid line. What is the thing that we need to check for next? That's right, Fabian. We need a test point. All right. So what test point do we want to use, if all possible, every time? That's right, Isaiah. We want to use 0, 0. So as long as our line does not go through 0, 0, we want to use 0, 0. So we're going to replace our y value with 0, less than or equal to 1/2. We're going to replace our x value with 0, plus 1. There is no value in front of the first 0 to multiply by, so we're just going to leave it 0. Then we're going to distribute. 1/2 times 0 is, well, 0, plus 1. We'll bring down our 0, less than, and then we have 0 plus 1 is 1. The question is asking, is 0 less than or equal to 1? What do you think, Fabian? That is correct. It is true because 0 is less than 1. It doesn't have to be both, just has to be 1. So since it is true, we shade on the side where our test point was, and this is where you would put your little bucket. You drop that bucket in right there. All right, so now turn in your books to page 397. I'll bring this back down again. We're going to go to page 397, and we're going to try a few. I want to make sure you see some that are in standard form as well as in slope-intercept form. All right, so let's go to page 397. Let's do 2 in slope-intercept form, and then we'll do 2 in standard form. And that way, that gives us an opportunity to see both before we move on to the final example for the day. All right, so we're going to do page 397 is where we're going to be, 397. And we're going to start and we'll do numbers 17 and 21. 17 and 21. So number 17, we have y is greater than 2x minus 6. So the first 2 we do are going to be in slope-intercept form. The next 2 that we do will be in standard form. So since we're in slope-intercept form, I'm going to write this down, slope-intercept form. We want to identify our m value, our m value. So our m value is who? What would that be, Tanaya? You're right, it would be 2. If I make this a fraction, how can I make that a fraction, Tanaya? That's correct. I can put it over 1. So now I know how many I'm rising to, and I'm going to right 1. So now we got to find our b value. So Cheyenne, what is our b value? That's right, it's negative 6. This is our y-intercept. And this is our starting value. So I'm going to go ahead and draw as our axis. All right, I knew we were going to go down 6, so I gave us a long y-intercept. So my y value, our starting point, is at negative 6. So I'm going to go down 1, 2, 3, 4, 5, 6. That is my starting point, way down here at negative 6 on the y-axis. That would be the first dot that I drop in. Then my slope is rise 2, run right 1. So rise 2 from this dot, 1, 2, and run to the right 1. Now based upon my inequality in my Math Excel for school, will I select the solid line or the dotted line? What do you think, Ava? Correct, the dotted line. Fantastic. So I'm going to have a dotted line. All right, now that I have my dotted line, what do I need now, Cheyenne? Correct, I need a test point. All right, Ethan, what do we want our test point to be? That's right, I want it to be 0, 0 because our line does not pass through 0, 0. All right, so we replace in my equation y with 0 greater than 2 times 0 minus 6 because my x value is 0 and my y value is 0. There is no value in front of my 0 to multiply by, so I'm going to leave it 0 in my symbol. Then distribute 2 times 0 is 0, take away 6. I'll bring down my 0. 0 take away 6 is negative 6. The question is 0 greater than negative 6? What do you think, Ethan? That's right, true. 0 is bigger than negative 6. So since 0 is bigger than negative 6, we drop our shade on the side where our test point is. So we would drop our little bucket over here. This is where your little paint bucket would be dropped. All right, so now we're going to try problem number 21. Number 21. So I'm going to bring the screen up a little bit so it's going to move on us. Let's try not to make it too nauseous. All right, number 21, we got y is greater than or equal to negative x. So again, I told you that this is also in slope-intercept form because the first two we're doing today will be in slope-intercept form. All right, so the first thing we can identify in slope-intercept form is our slope. So Cheyenne, what would be the slope of our line? That is correct. It would be 1. It would be -1 because there's a 1 in front of that x that you don't see. That's the coefficient. So we have a -1. So my slope is -1. How can I make -1 a fraction? That's right. Ethan, I can put -1 over 1. That means I'm going to fall 1, and then I will run right 1. All right, then I need to determine my b value, my y-intercept. What do you notice about this problem, Lakeisha? That's right, there is no b value back here. So my b value is 0. So that is my y-intercept. It is also my starting point. All right, so I'm going to go ahead and draw our little graph. All right, I'm going to go ahead and plot our first point, which is at 0. Right there on the marker, 0, 0. It's been plotted. My slope is -1 over 1. So I'm going to fall 1 and run right 1. Now, will my line be solid or dotted, Ava? That's right, a solid line. So we'll draw a solid line right through my points. All right, now we need a what, Fabian? That's right, a test point. But notice this time that our line goes through 0, 0. So we can't use 0, 0 as a test point. We can use any other point on the graph. So if my line goes through 0, 0, I'm going to choose the test point 1, 1 because those are easy numbers. 1 and 1 are pretty easy to use. But you can pick any value that you really want. So we'll replace y with 1 because my x value is 1 and my y value is 1. So y with 1. Remember to always use those parentheses when you're substituting. And my x value is 1. There is no value in front of my 1 to distribute, so it just stays 1. Greater than or equal to, I'll distribute. -1 times 1 is -1. So it's asking, is 1 greater than or equal to -1? So Tanaya, is 1 greater than or equal to -1? Correct, that is true. 1 is greater than or equal to -1. So we're going to go ahead and shade on this side where our test point was, or drop our little paint bucket in there. That's where your little paint bucket would be dropped in. All right, so now we're going to move on to page 398. We're going to do some standard form examples of this. So I'm going to bring this back down, switch out the paper real fast, bring this back in view for you guys. And I'm going to be on page 398. So in case you've lost track or didn't hear what I said, we're on page 398. And we're going to do problem number 26. And we're going to do problem number 27. So 26 and 27. So 26. Problem number 26 says -2x plus 1y is greater than or equal to 3. So this is in standard form. With standard form, you have two options. You can solve this and get it in slope-intercept form to make it look like the problems we did just a few minutes ago. Or we can solve this by graphing with the intercepts. And we usually are okay with that as long as those values will fit on our graph. We have values for them. So I'm going to show you how to change it into slope-intercept form. So we're going to first convert. So we're going to say standard form, and so we're going to say convert to slope-intercept because I think it's much easier for you all. All right. So to convert to slope-intercept form, which is y equals mx plus b, we need the y to be all by itself on the left-hand side. Well, over here, the x is on the left-hand side with it. So how can I move a minus 2x over here to the right side? That's correct. We add, because the opposite of minus 2x is plus 2x. We got our plus y, our inequality sign. And if I add 2x on the left, I have to add 2x on the right. All right, so now here we go. Negative 2x plus 2x cross each other out, leaving me with my y is greater than or equal to. So now before I go write these down, look at these and look at this order of mx plus b. And mx plus b, notice the x and its coefficient come first, followed by the b value or the constant last. So my x and its coefficient of positive 2, so positive 2x should come first, and then the constant of positive 3 should come last. Now we're in that slope-intercept form, so now we can quickly identify who our slope is and who our y-intercept is. So looking at that problem, who is our slope? Ava. That is right, it is 2. Now Ava, how can I write that as a fraction? You're correct, 2 over 1. Fantastic job, girl. I'm so proud of you. So this tells me how many I need to rise and how many I need to run right. All right, Laquan, what is my b value? That's correct, it is 3. And that is my y-intercept. And it is my starting point. All right, so I'm going to go ahead and draw a little graph for us. All right, so here we go. My y-intercept is positive 3. So I'm going to go up 1, 2, 3. That's my first dot right there. My slope is 2. So from this dot, I'm going to rise 1, 2. And then I'll run right 1. Will my line be solid or dotted, Cheyenne? That's right. I'll have a solid line. Solid. There we go. Now, what do I need, Isaiah? That's right. I need a test point. So what might my test point be? That's correct. I can use 0, 0 because my graph does not pass through the 0, 0. So I'm going to replace x with 0 and y with 0 because x is 0 and y is 0. So I've got 0 is greater than or equal to 2 times the x value plus 3. So I got my 0 where I substituted in for my y value. I'll bring this up a smidge. As you notice, there's no value in front of my 0 to multiply by, so I'll leave it just 0. Distribute, 2 times 0 is 0, plus 3. So bring down my 0, and then 0 plus 3 is 3. The question is 0 greater than 3? What do you think? Ethan, is 0 bigger than 3? You're correct. That is not true. That is false. 0 is not greater than 3. So since this is a false statement, we cannot shade on the side of our test point. We shade opposite of our test point, and that's where you would drop your little bucket in at, on the opposite side, because this is a false, which means this side would be true. So when you graph these lines, one side is true and one side is false. You will always shade on the true side, not the false side. All right, we're going to do problem number 27. So I'm going to bring this up. Here we go. Bubba Joe's. Number 27. All righty. We got x plus 3y is less than 15. All right, Lakeisha, what form is this in? You're correct. This is in our standard form. And Angel, what form are we going to change it to? That's correct. We're going to change it to slope-intercept form. All right, Tanaya, what would be slope-intercept form? That's right. It's y equals mx plus b. All right, so what would I have to do first, Ethan, to get this in slope-intercept form? Who do I need to move? That is correct, Ethan. I need to move the x from the left side to the right side. So how do I move this positive 1x to the right side? You're correct, Ethan. I subtract. So I have positive 1x, I add minus 1x. And if I subtract 1x on the left side, I must subtract 1x on the right side. So x minus x cross each other out, leaving me with a positive 3y is less than or equal to. Now, I want to put it in the right order. So remember, I need my value with my x first. My coefficient and my x have got to come first. This is my x, and the coefficient to my x is a negative 1. So that negative 1x must come first. Then my plus 15 will come next. Unlike our other problem that we did on 26, the y is not by itself. It has a 3 attached to it. So Cheyenne, what is the opposite of multiplying by 3? You're correct, dividing by 3. So if I divide this value by 3, I must divide the first term over here by 3 and the second term over here by 3. We want to divide across the board because we want to be fair. We don't want to leave anybody out, and we don't want everything to balance, because if we don't, it doesn't balance out. So 3 divided by 3 is 1, and 3 divided by 3 is 1. So now we have 1 times y on the top, which is just y, divided by 1 is still y, less than or equal to, because we did not divide by a negative value, we divided by positive, so my inequality stays put. Remember, there's a 1 right here we don't see. So is negative 1 divisible by 3? You're correct, Cheyenne, it is not. So it stays negative 1 over 3 and then our x. Then what I'm going to do is 15 divisible by 3. Laquan, is that true? Yes, what would it be? You're correct, 5. So now I am in slope-intercept form. So now I can identify who my slope is and who my y-intercept is. All right, Mia, what is my slope? You're right, negative 1/3. Since my slope is negative, this means I will fall 1 and I will run right 3. What is my b value or my y-intercept, Ethan? That is correct, it is 5. So this is my y-intercept. Or my starting point. All right, so from here, we can go ahead and start graphing. So I'm going to go ahead and create my graph. All right, so here we go. My starting point is at B on the y-axis. Remember, this is my y-axis. So I'm going to go up 5. 1, 2, 3, 4, 5. That's my first dot at 5 on the y-axis. My slope is negative 1/3. So I'm going to fall 1. And then I'll run right 1, 2, 3. So I'm going to fall 1 and run right 3. Will my line be solid or dotted, Isaiah? That's correct. I've got this equal to bar, solid line under my inequality, which means I'm going to have a solid line. There we go. Try to make that a little bit better for you guys. All right, so now what do I need? That's correct, Mia. I need a test point. Okay, what do you want my test point to be, Shai? That's right, 0, 0. Because this graph does not cross through the 0, 0 marker. So my x will be 0 and my y will be 0. So now I have 0, that's where I substitute in for my y, is less than or equal to negative 1/3 times 0 plus 5. There is no value in front of my 0 to multiply by, so I'm going to leave it 0. Negative 1/3 times 0 is 0 plus 5. So I got my 0, and then I got 0 plus 5, which is 5. So now I got to ask myself, is 0 less than or equal to 5? What do you think, Amaya? You're right, it's true. 0 is less than 5. So as long as it meets one of the qualifications, it could be true. So we would shade on the side of our 0, 0, or drop our paint bucket over here on this side. So again, one side will always be true and one side will be false. It all depends upon whether or not your inequality that you create with your test point proves to be true or false. All right, so now we're going to move back to page 395, and we're going to go back and finish example number 3. So we go ahead and switch this around, get this back into view. We're going to do example 3. So for example 3, we're going to do graphing a linear inequality in one variable. So graphing a linear inequality in one variable. All right. So to do this, we're going to first look at the example they've given us. And so we need to realize what they're asking us about. So one variable means we're either going to have just x or we're going to have just y, but we're not going to have both. So if we have only x as our variable, this would create a vertical line. If we have only y, this would create a horizontal line. And the rule still holds true whether it's solid or dotted based upon whether your inequality has that equal to bar or it does not have that equal to bar. All right, so we're going to look at our first examples. We're going to actually look at, there's 2 on this page we're going to look at. We're going to have one with an x and one with a y. So the first one's going to be our x. So it says x is greater than -1. So again, we only have the one variable, which is -1. And with these, you don't really need test points. You're just going to use your understanding about a number line. So I'm going to put our little number line, our little graphing here. There's our coordinate plane. When you only have one variable, you're going to graph, you're going to go to -1 on the x-axis and make your first point. All right, so here we go. We're going to go to -1 on the x-axis and we're going to drop it in. So you're still grabbing that line tool. But to make your second line, because we know it has to be a vertical line because this is an x-only equation, vertical means my line has to go straight up and down. So I'm going to be a dotted line, and I need to pick any point else on that dot. It does not matter where. I can pick it above it. I can pick it below it, just as long as it's on there and it creates that dotted, dotted, dotted vertical line. So it's important that we have this vertical line going on. So we have to create a vertical line. The next question is asking us, you can still do a test point if you want, or you can use what you know about your number line. So we'll do both. First, we'll talk about what we know. It says x is greater than -1. So we want to shade all values that are bigger than -1. So if this is -1 right here, are the numbers to the left of -1 bigger or the numbers to the right bigger? That's correct. The numbers to the right are bigger. But we could still do this with a test point. And we could still use our test point of 0, 0. But we only really need the x value since we only have one variable. So we'll replace our x with 0 and greater than -1. And again, there is no value in front of our 0 to multiply by, so we'll leave it 0. Is greater than -1. So we ask ourselves, is 0 greater than -1? That is true. 0 is bigger than -1. So there was our test point that held true. So we would shade on this side. Or we would drop our little bucket over here on this side. So again, numbers greater than -1 are to the right of it. Or you can do your test point to see if it holds true. All right, so now we're going to do our second example with a y-only equation. So I'm going to move this guy up. All right, so we're going to do y is greater than or equal to 2. So we're going to go ahead and draw our line, our little coordinate plane here. Since we only have a y value, we will go to positive 2 on the y axis and make your first point. All right, so here we go. We're going to go to positive 2, 1, 2, and put our first dot on our line. Because, we'll bring this back down a smidge so we can go back and review, only y's are horizontal lines. We have to make sure we're creating a horizontal line. So we're going to go to our 2, and either you can put a point, your next dot can be to the right or to the left. It doesn't matter where you put that dot, where you drop the second point at, just as long as you create the line that's horizontal. So now, would our line be solid or dotted? That's right. We have this equal to bar, which has a solid line, creating a solid line through there. So again, we need to have a horizontal line. So when you only have one variable, your line will either be vertical or horizontal. It will not have any slant or slope to it. All right, so here we go. We're going to use our test point. So let's try a test point. What test point do we want to use, Angel? That's right, we'll use our 0, 0. There it is. We're going to ask ourselves, we're going to place our y value with 0. And again, there's no value in front of our 0 to multiply by, so we'll just ask ourselves, is 0 greater than 2 or equal to? So Angel, is 0 greater than or equal to 2? You're correct, that is false. 0 is not greater than or equal to 2. That's a false statement. So we cannot shade on this side because that represents the true side. We'd have to shade on the false side. Or all values bigger than negative 2 or above. All right, so we're going to flip on over to page 398, and we're going to try number 23 and number 24. So I'm going to go ahead and bring this back down. And we're going to go to page 398. We'll bring this back in view. We're almost done. And we're going to do problem number 23 and 24, and that will complete our lesson. So number 23 is y is greater than or equal to negative 1. So first question for you, Lakeisha, would this be a vertical line or a horizontal line? Correct. This will be a horizontal line. How do you know it's horizontal and not vertical, Lakeisha? You're correct. It says that y is our only variable. So if the only variable we have is y, horizontal line. All right, so I'm going to go ahead. We can start graphing. All right, so Angel, where do we start? That's correct. We go down 1 to negative 1 and put our dot. All right, Isaiah, where will our next dot go? You're correct. It can either go 1 to the right or 1 to the left. It doesn't matter. Will our line be solid or dotted, Mia? That's right, solid, because we have this equal to bar, so solid line. All right, Fabian, what will be our test point? That's right, Fabian, our test point is 0, 0. So there's my test point. That represents the true side. So if it's true, I shade here. If it's false, I shade here. All right, so I'm going to place my y value with 0, greater than or equal to negative 1. There's no value in front, so we'll distribute. Nothing to that, leaving it 0. And the question is 0 greater than or equal to negative 1, Fabian? You're correct. That is true. 0 is bigger than negative 1. So we're going to shade on the true side, that's where our test point is, or drop our little paint bucket on the true side. All right, almost done. Problem number 24. X is greater than negative 2. All right, Cheyenne, would this be a horizontal or a vertical line? You're correct. This will be vertical. How do we know it's vertical? You're right, Cheyenne, because it has an X only. So X only, vertical line. All right, we're going to go ahead, draw our graph. All right, so where will my first point be, Cheyenne? That's correct. I'm going to go to -2 on the X-axis and put my first dot. All right, Amaya, where do I put my next dot? That's right, either above or below. All right, so Laquan, will my line be solid or dotted? That's correct. It would be dotted because I don't have an equal to bar. No equal to bar, dotted line. All right, so Maya, what would my test point be? That's correct. My test point would be at 0, 0. So I'm going to let x be 0. 0 there, sorry, bad 0, and -2. There is no value in front of my 0 to multiply by, so I'll keep it 0 is greater than -2. So I got to ask myself, put my little test point. Remember, this is the true side, this is the false side. So this is the true side, this is the false side right now. Because wherever my test point is represents the true side. So now, is 0 greater than -2, Mia? Yes, you're correct, it is. So now I would shade on this side where my test point is. And this is where I would drop my little paint bucket at. Everybody okay? All right, I hope you guys understood the homework today or the lesson today. The homework is available to you guys online. So you'll log into your Math Excel. There's only a few questions, I think like 5 maybe. So go ahead and work on those. If you got any questions, please feel free to reach out to me through Remind. I love you guys. I hope you have a great day, and I miss you all so very much. Please stay safe, and can't wait to see you soon.